Okay, today we are going to talk not about a volume for a couple of minutes, but for about arc length. And you actually learned arc length of like a circle in pre-calculus, and arc length is a length and it comes from adding up the distance formula a whole bunch of times, and hopefully you looked at that because I'm not going to show you that because it takes too long to show you. But if you did the reading, um, basically if you have all these different points, let's say I want to know the arc length from here to here, so this length, I can add up the distance if I pick a whole bunch of points and add up all these little distances to find the arc length. And when you add up a whole bunch of small distances, that's where we're going to have our integral from. So arc length is found, and we usually use S for arc length in math. So S equals arc length from whatever two spots, A to B. So from here to here, here's A, here's B. The arc length is the square root, just like the distance. Remember, the distance formula is the square root of x minus x squared plus y minus y squared. And in the world of calculus, the arc length, when you add all these up, what happens, and they show you this step by step in the book, is that you get 1 plus the derivative squared, because you're looking at the change in x and the change in y and the change in x and the change in y. So you get 1 plus the function's derivative, that whole derivative, squared. That's how you find arc length. We're not finding a volume, we're not finding an area today, we're just finding arc length. So how far is it from here to here? What is the distance from there to there? So let's try one. Let's say you have the function y equals 2x to the 3 halves plus 3, and we're going to look at the arc length from 0 to 8. Um, Sometimes it's helpful to graph these. I'm not going to graph this one right now. I'm just going to show you how to actually use this formula right now. So I'm going to go from 0 to 8, and the square root of 1 plus, I need the derivative of this, so y prime. The derivative of that would end up being 3x to the 1 half, and then that's just 3. So we get plus 3x to the 1 half squared. And always do any algebra that you can inside the square root first, because some of these are really weird integrals. And actually, there's a section in the book that some practice problems we're not going to do that says set it up, but you don't have the techniques yet to solve them, because we really haven't learned all the integration techniques. That's part of our job in Calc 2. But this one we can solve. We get 1 plus, that would be 9x. So a u substitution, u equals 1 plus 9x. And so you get the square root of u. I remember you can do these different ways. You can either keep 0 and 8, or you can change them right now. I'll just keep them for right now. So if I integrate the square root of u, oh, look what I forgot. I need the derivative of u, which would be 9, right? So I gotta put a 1/9 out here. I apologize. There we go. So I get 1/9, and if I integrate the square root of u, I would get u to the 3 halves, and then that'd be 2/3. So I get 2/3 u to the 3 halves, but my u was 1 plus 9x to the 3 halves, and then I'm going to integrate that from 0 to 8. And I have no idea what that is, but it equals some number. I'm trying to think, see if I solved it. I did not solve it. So that's a number, whatever it is. The other thing that I was going to say here is I could have wrote this as 1/9, and I would go from, if I put, instead of having to substitute back in for u, I think I showed you guys this last year, I can just put in 1 here, and I would get 73 here, and then I could just do square root of u, so I'd get 1/9. This would be 2/3 u to the 3 halves, from 1 to 73, which is the same weird number, whatever that number is. So you'd plug that in your calculator and get that. All right, sorry. All right, let's just try one more. Let's try y equals the natural log of the cosine of x, and we're going to look at that on the interval of from 0 to pi over 3. All right, so you're going to integrate from 0 to pi over 3 the square root of 1 plus this function's derivative squared. So this function's derivative, y prime, would be 1 over the cosine of x times negative sine of x, which is negative tangent of x. And so then you get plus negative tangent of x squared. So you have the integral of 0 to pi over 3, the square root of 1 plus tangent squared of x. Now remember I said do anything in the radical that you can first. Well, here's what I can do in the radical. This is an identity from trig, and it's also on the back of your cheat sheet. 1 plus tangent of x is secant squared. And the square root of secant squared is secant. So if I integrate that using my little cheat sheet, I get the natural log of the absolute value of secant of x plus tangent of x, oops, from 0 to pi over 3. And I don't know what that is. I guess I could figure that out. The natural log of secant at pi over 3 is 2 plus the tangent at pi over 3 is square root of 3 minus the natural log. The secant at 0 is 1. The tangent at 0 is, what is tangent at 0? That would be 0 over 1 is 0. And right here, minus the natural log of 1. Remember, the natural log of 1 is 0. So this is my answer. Okay, that's it. Have a wonderful day. I will see you in class.